Geometry lesson 4-4. Last time I gave you two postulates you could use for congruency of triangles. Side, 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 and side, angle, side. I'm going to give you two more today. The first one is known as angle, side, angle. And I want you to think about all these triangles in a word known as rigidity. Alright, so rigidity, if you think about that, is rigid, something that can't change. And if I'm dealing with a triangle and I don't have the ability to open the angles and make them wider or skinnier, then things start to get a little more rigid because they're locked in. And if I lock an angle in, like I lock the angle in between my fingers, the distance between my fingers has to start to get pretty much locked in as well, because the only way that distance between my fingers changes is if the angle starts to change in here. So angle, side, angle is another way of looking at some form of rigidity. This is saying that two angles and the sides that connect them. So two angles. Angle on this side gets locked in. Angle on this side gets locked in. So I've got a triangle with two angles that are locked, like so. The only thing that could change now is how close they are or away from each other. That could manipulate the size of the triangle. But the moment the side that's between them, right here across my thumbs, the moment it gets locked, I now have some rigidity, and there's only, there's got to be some values here that create the rest of this triangle. Only way the triangle would get bigger is if I had the ability to break apart my thumbs, and you can't if we're dealing with angle, side, angle. It's angle, side, angle that's locked in. The triangle is rigid. All right? So if an angle, side, angle of one triangle are the same as angle, side, angle on another triangle, you will have congruent triangles. The other one is angle, angle, side. Now this is two angles in a row and then a side that is congruent. Now this is a non-included side. Before, when I did it for angle, side, angle, it was actually in between. This is telling you the order that you need to go. Start at an angle, go to a side, finish at an angle. This is saying start at an angle, go to another angle, and then a corresponding non-included side that matches up. That's really important. Non-included side, and it must be the corresponding. Now people are like, I don't understand what you mean by that. So let me draw a real quick triangle. Alright, and this is about as quick as it needs to be. Now I'm going to clone it, because obviously those two are the same. If I clone it, then you'll believe me. What this is saying is, if you have an angle and another angle that match up, and then a corresponding non-included side. Okay, so I'm going to twist this up a little bit. Apparently it didn't group. I think I got the lines didn't get... Okay, should work now. Alright, so no matter how it's oriented now, what's important is you've got to think about included side would be right here. I'm not talking about the included side. That brings us back to angle, side, angle. Right? This is angle, side, angle. Angle, side, angle. I don't want the included side. We're talking a non-included side that has to be corresponding. So if this side and this side were corresponding, which they are, because that's the side just above that one, all right, connected into it, then I would be okay according to angle, angle, side. But if this side matched up with that one, that would not be good enough. This would not be an example of angle, 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 side. You're thinking, but it has the angle, and the side, has the angle, and the side. True, but it's not corresponding. This side does not correspond with that side. How do you know that, Mr. Gorey? Because this is going from the arc, the angle I don't know, into the one with one arc. This is going from the angle I don't know into the angle with two arcs, which means it's not the same side. Right? Before I actually rotated these, if you recall, they were the same right there. I would need this green line to be on that side, right there. If that were the case, then I could say this is the same because of angle, angle, side. They would be congruent. Okay? So our first example, is it possible to prove congruency? Based on this situation, you've got this angle matches up with that angle, this angle matches up with that angle, and in fact, these these two match up with each other as well because they're vertical angles. But is that enough to say angle, angle, angle? We would have to say no. Even based on the drawing, it looks like that triangle is smaller. So we would say no. You must have at least one side involved, whether it's side, 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 or it's side, angle, side, or it's the new stuff today, angle, side, angle, and angle, angle, side. There's always at least one side involved. Is enough here? Now somebody's going to tell me the same thing. They're going to say, no, that's not enough. And somebody else might say, yeah, it is the same because remember that third angles theorem you talked about, Corey? If you had two angles that are the same on both, that means that this one has to be the same as this one over here. And I would say, yeah, but like last time, just because we had three angles that were the same isn't enough. But what you need to realize is that there's actually two triangles here. Two triangles. And since both the triangles are sharing that same side, that means they're congruent to each other. That side is congruent for both triangles. So you now have an angle, a side, and an angle that matches up with an angle, a side, and an angle, which sounds a lot like angle, side, angle. Just remember, it's not angle, side, angle, that angle, side, angle, because that wouldn't be corresponding. All right? Now, we're not going to actually go through a full proof, but we're just going to kind of think about what we have here. We have a proof that we're trying to get BDM, this triangle, is congruent to CFM. We want to make sure that they are the same based on some given information. One is that angle B matches with angle C, and D matches with angle F. It looks like it's a right triangle or right angle, but I don't know that to be a fact, so I'm not going to mark it with right angle signs. One other piece of information is the fact that M is the midpoint, which means it's in the middle of these two. Now, according to what you see, you have an angle and another angle. An angle and another angle that match up, and there's a non-included side that's in the corresponding location on both of these. If that green line hadn't been there, if this green line had been here, that would not be good for us in trying to prove congruency. But because it is down there, because it's the midpoint, we know we're dealing with angle, angle, side. So we would say this is true, and the reason is angle, angle, side. Once we've labeled all the information, angle, angle, side.